This is Greg Troutwine with Marine Technology TV, and we're very pleased to be joined today by Timmy Gambin, the University of Malta, and Stefan Renason, Teledyne Govia, to discuss how the University of Malta is using its Govia AUV to assist in its underwater shipwreck search and underwater mapping projects. Professor Gambin, to start, can you give us a brief overview of your responsibilities and program at the University of Malta?
Yes, first of all, thank you for having me on this very informative program. My responsibilities are varied. From an academic point of view, I coordinate our masters in maritime archaeology. This year we've got 7 students from different corners of the world, from the States, Greece, Canada, Malta as well. So it's a pretty international course. Then besides the academic part, the teaching part, I also direct fieldwork as part of the maritime archaeology program. And one of the biggest parts of our fieldwork is actually going out with our AUV surveying the seabed.
Focusing specifically on your search for shipwrecks, can you discuss the size, shape, and depth and/or other interesting characteristics or challenging characteristics of the territory in which you work?
So our strategy is to survey all Malta's territorial waters, which measure about 3,500 square kilometers, but minus a bit, because we only survey from 50 meters, from the 50-meter contour, so that's 150 feet, down to whatever depth are present in our territorial waters, which is about 1,100 meters. The reason being that we believe that most of the archaeology, shipwrecks and aircraft, etc., that are situated shallower than 50 meters have mostly been found by scuba divers, or they are covered by weed and grass, or a combination of seaweed and seagrass and sediment. So so far our AUV is good to 500 meters. We're currently looking at funding to get this rated to 1,000 meters, and that will help us cover most of the seabed in our territorial waters. The topography is pretty conducive to survey. I mean, where we have slopes, we have gentle slopes. We do have a couple of seamounts, so that takes specific planning to survey around them. But overall, things have been moving smoothly. We started with a towed system and now have moved on to this AUV for the past 3 years. We still have a lot to go down to the 500-meter contour, but the results so far have been pretty spectacular.
Professor, can you give an overview of the technology toolbox deployed today that are used to make your missions more efficient and successful?
Okay, so since 2018, when we acquired the AUV, this is our sole tool for searching. We have the payloads that our AUV carries is a side scan sonar, dual frequency side scan sonar, so 600 kilohertz for the main survey work and 1,600 for our higher resolution work. The Govia software is ideal for us because it's very easy to train our students. It's very easy to utilize. It's also very easy to switch parameters once the AUV is up in order to get higher resolution sonar imagery. Besides the side scan, we also have a multi-beam. We'll be doing some experiments later, well, not this year, but in 2022. And it comes with a whole host of navigation suites, forward-looking sonar to avoid collision, etc. But the main tool for which we use our AUV is side scan sonar.
Looking back 3 years ago, when the decision was made to acquire an AUV, what were the drivers? Why was the decision made to select the Govia unit?
Well, first and foremost, we had to look at what we had been using, which is a towed system. And with the towed system, we still have our towed system with a winch, which has 500 meters of armored cable. But realistically, you need a specific boat that can take that winch with all the weight. You can only work probably with a depressor wing on your towfish down to 200, 230 meters with that amount of cable out. And it's also a question of time. Working with an AUV cuts your work time by a significant percentage because you don't need to recover the cable in your turn. So that is what pushed us towards an autonomous system. When coming to choose which AUV, this being such a large project, such a large purchase, rather, the call was placed as a public tender, so anybody from anywhere in the world could submit a proposal, and Govia simply ticked all the boxes, not only with regard to simplicity of use, as I just explained, but also it's a modular system, so we can make it as big or as small as we can, obviously, as we like, rather. So, for example, we can reduce the size of the AUV and deploy it from a small reinforced inflatable boat, from a rib. We can deploy it with all the tools. That makes it slightly larger, but it's still deployable from a normal boat. And besides that, it's relatively robust not just physically, but also with regard to bugs in the software and so on. And I must say, although I didn't know it at the time, looking back, Govia have an incredible after sales service. I've developed. We're nearly on the level of friendship with the technicians. Not so much because we've had a lot of trouble. It's because sometimes, after winterizing the AUV, you need to get back up to scratch, and the Govia technicians are just a call away, and they've been absolutely great.
So, Stefan, I appreciate you joining us as well. Can you provide some in-depth technical specifics on the Govia AUV system that's deployed by the University of Malta?
Sure. So the Govia AUV that the University of Malta procured is as Timmy said, is a 500-meter depth-rated system. It's a fully modular autonomous underwater vehicle, which means that you can reconfigure it on the back of the deck of the ship or in the lab prior to deployment. And you can do battery swapping and actually have longer duration missions and get the data at the meantime as well. It has a inertial navigation system, an IX Blue C3, coupled with a Teledyne RDI Workhorse DVL for subsea navigation. That subsea navigation is also enhanced with a directional acoustic transponder, or DAT, which is a mini USBL system made by one of our Teledyne sister companies, Teledyne Benthos. We use the Teledyne Benthos acoustic equipment as well for communication with its subsea. Then for the sensor package, they have an EdgeTech 2205 dual frequency side scan sonar, the lower frequency at 600 kilohertz and the higher frequency at 1,600 kilohertz. They also have a MB2250, which is a blue view multi-beam at very high resolution at 2.25 gigahertz. That can be used for microbathymetry and extremely high resolution multi-beam detection.
As Professor Gambin said, you have a close relationship. What do you consider to be the best lessons learned from your relationship with the University of Malta?
Mostly the novel use of the equipment that we made for a commercial survey. They're our first client with a focus of underwater archaeology and wreck finding. And for us, the utilization of our commercially made sensor suite, that it fits so well within the mission profile of the University of Malta, as well as the ease of use that they've had with the ever-changing students coming in and out into their program. That has always as well been a fantastic lessons learned for us, that we're getting some feedback of how to simplify the system and make it better. And we've been trying to utilize that feedback as well.
Professor Gambin, I know that you have many significant finds, but as an overview, can you give a by the numbers look at your work to date using the metrics of your choice?
These are always the hardest questions to answer. The number of finds is so numerous that we haven't actually, I cannot give you a definitive number. But what I can say is that from this February, we're going to start incorporating all the data into an updated database, and therefore we'll be able to crunch numbers and come up with a clearer answer and a more definitive answer than I'm giving now. It's literally dozens and dozens. The other thing about using side scan with an AUV is the complete clarity of the data. When for those of your listeners who know, and also those who may not know, but when you use a side scan with a towed system, the vibration of the cable, of the hundreds of meters of cable you have, is translated into your data set. Whereas with the AUV, it's so smooth that you get this crisply clear and high resolution data. To give you an example, one of the major projects we're working on now is we've partnered with the Italian Superintendents of the Sea and the RPM Nautical, and we're using the AUV to survey the area of the Battle of Egades. This is a battle fought in 240 BC between the Romans and Carthaginians. Whereas usually, let's say off the coast of Malta, we're looking for anything from fragments of a plane, large fragments of a plane, to an entire plane, to an ancient shipwreck, which looks like a pile of rocks, to large modern shipwrecks in Sicily in the Battle of Egade survey. We're actually looking for things as small as swords and bronze rams, and we're picking them up. So we've been working off the Egade Islands for 3 years now, for 3 seasons. We're going back for our 4th season in 2022. And it's been an eye-opener. I've been using SideScan for over 2 decades, and I was pleasantly surprised with the amount of discoveries that we're churning out of the Egade Island. So watch that space. Perhaps you'll have me back and discuss this particular project in more detail.
That sounds like a good plan. Professor Gambin, I appreciate your time. I just had one more question. You've already named a few. I know the by the numbers look is painful because it's ongoing and it's voluminous, but can you discuss the 1 or 2 discoveries using the Govia AUV that you personally consider to be the most interesting or historically relevant?
Well, it's like asking me to name, my favorite son, which is impossible. But there are two shipwrecks that stand out, at least now. One of them is HMS Edge. The University of Malta was commissioned by the grandson of a submarine commander whose submarine was lost in 1942. She left Malta on her way to Alexandria, never turned up in Alexandria, and nobody knew where she was lost. It was claimed that she was found off Libya. which would have brought dishonor on the commander and his crew, because it means that it meant that he would have broken his disobeyed his orders. So we were commissioned to look for this submarine. We designed the search areas around the German and Italian minefields, and we located her in 2019. And so that's very important from a human level. We're commemorating the loss of the submarine in April of 2022, which would be its 80th anniversary. And the last time I was in touch with Francis, who's the grandson of Commander Tompkinson, there are about 80 family members who are traveling to Malta for this event. So you can also make the link between sort of the technology that's being used, what it's being used for, and in some cases, especially this one, the link to the human story. So that's one. The other one, very quickly, because I'm running over time, I think, is with the Govia, we also discovered an incredibly rare Renaissance shipwreck. So a shipwreck that dates from the early 1500s, early 16th century. Studies are ongoing, so I can't really say much more. But it wasn't an easy shipwreck to find because it's spread out over a wide area, not very heavy features. So, you know, the steadiness of the Govia and the resolution of the sonar data permitted us to discover this pretty unique site.